Hello everyone. Previous session I have explained something about Hibernate and ORM, um, Log4j, all other stuff, right? And in that session I was talking about design pattern, right? So Hibernate uses so many design patterns. When Spring Framework came into market, uh, in development or developers or architect, they stopped into implementing design patterns directly. These design patterns, what is that? We'll talk today, and I will implement maybe few design patterns and show how it actually helps us. So let me share my screen. In initial days when I started my career, right, at that time in few of the application, old application Spring pattern, Spring was not used, or Spring framework or Hibernate framework, these were not used. So in that particular case, I have written few patterns, you know, and design patterns to solve some issue which were actually happening in the application. Right? If you see, there are so many things which actually create trouble. We need to know what need to be done, what need not to be done. Right. So here I've created a project. I'll push this project into this simple Eclipse project. Now Maven is attached here. It's a simple Eclipse project. I'll push this project to Git. You all can see the code. Yeah. So talking about design pattern, right? So I'll just go, since I don't prepare PPT for technical sessions, I'll just go for design pattern and I'll open one website and from there I will explain. Right? Maybe Geeksport has given a beautiful diagram. Somewhere I've seen beautiful diagram. Or let me see images. Oh, beautiful diagram somewhere I have seen. Let me open the diagram if I can open it. Let me open one of the diagram. Yep. Let me open. This is from Medium. Medium website. You can go to Medium website and you can see they have explained very well. Even if Geeks for Geeks, even if Hacker Rank, Tutorials Point, Java Point, so many websites are there. Those who have explained very well in design patterns, right? So see, this is the design pattern, and I need this diagram. That is the reason why I have opened this particular website. This diagram was, very perfectly presented. See, what is design pattern first of all? Design pattern started from Gang of Force, right? So if you read design pattern history, you will find very beautiful explanation about it. The book is the Gang of Force, right? You read that book, you will come to know uh, design pattern, Gang of Four. There will be, yeah, Gang of Four design patterns. See, this is design patterns, Gang of Four design patterns, right? So see, what is actually design patterns? I will tell you now. This is the book, design patterns, object-oriented or elements of usable object-oriented software. Erich Gamma, Richard Helm, Ralph Jason, John Millsacks. You can purchase this book. You can read. This is very good book. You can purchase and you can read. There are so many books are available. Depends on you whose writing you like. Purchase. You can read it, or you can find so many videos, so many things on internet. So for me, what I will go and do here, I will not explain everything, all the design patterns, but what creational, what is structural, what is behavior, I will explain that. And then, I will explain some examples from there. Like if I go for creational, let's say in creational, I will explain singleton and factory. So like that, I will choose uh, one or two design pattern and I will explain it. So what is design pattern? Design pattern, design pattern, let's say you have a problem and recurrently that problem is happening, continuously that problem is happening, not only in a new application, maybe in many of the applications, right? So to solve that problem, a solution is already identified and tested, and that solution, you know can be reused whenever you see similar kind of implementation or problem. So that actually helps you to fix your issue. So design patterns are basically reusable solutions, reusable solutions for a pattern or for a problem, right? So that same definition might be given here, right? Let me go to this guy, design pattern. Design pattern is a reusable solution to a common problem that occurs in software design, right? So this is see, it's not only software design. Here they have here the author has mentioned for software design because we are talking about digital patterns of software. If you see in construction industry, if you see in logistic industry, if you see in banking industry, or if you see in corporate world, other than software, if you see in all other places, everything is getting upgraded. And there will be some problem in some places. For that, they would have identified some solution, and that solution is kind of a reusable solution that can be reused. Let's say in logistic, one problem is there, and not software, some other problem, right? The kind of stockroom problem, the where you keep lots of stock and then publish it to the main store or transfer it to the different branches of store. See, they use so many patterns, so many different algorithms or behavior. These are kind of patterns only. These are usable solutions, for particular problem. It's not only in software, but in other industry they also have patterns, also they are reusable solutions. So in software industry for these reusable solutions, we call it a design pattern. Reusable solution for a problem is called as design pattern. And in design pattern, we have kind of creational, structural, behavioral. This kind of three patterns are there. What is creational? What is structural? What is behavioral? See, creational pattern is kind of a pattern which helps, in creating objects. In creating objects, how we can create an object. There are so many, approach to create an object. You know. So there are singleton pattern, factory pattern, abstract pattern, builder pattern, prototype pattern, right? These are the pattern. So what I will do, I will just explain this pattern definitions, what this pattern say, maybe all these patterns, and then I will go and show you in creational design pattern, singleton pattern, and what is factory pattern. Similarly, abstract factory, prototype pattern are also similar kind. Similarly, you will implement it. You can do it your own, and if you read the theory, you will learn pattern easily. See, singleton pattern, what it actually does. Singleton pattern creates an object, a single instance, not more than that. Singleton pattern will help you to create only a single instance throughout the application. When the application starts and end, throughout the application lifecycle or the request lifecycle, you can say throughout the request lifecycle, it will have only one single instance. For that particular main thread, till all the for the particular main thread, it will have only single instance. It will not create multiple instance for that object. That is called singleton. And factory pattern is something like it's kind of a factory which will produce different object and give you back. You are not going to create instantiate or create an object, but factory will create an object for you and it will give you. Right. So see, now I will go to Eclipse and show you this singleton pattern, right? See what I have done in one of the previous session. I had one object. I had one object that is employee object. So I will take that object and create a singleton pattern for that. But that is not the actually way to do it. If you have seen in JDBC, we have connection object. If you have seen in JDBC, we have or in in JDBC we have connection object. If you have seen my previous session, Haven session, you will find a JDBC connection object. So see, you should get one connection for that particular main thread. And using that connection, you should execute all insert, delete, update all the operation. How you can, how you will do that? In each method, if you write a connection, new connection, so what will happen? You're going to create one new connection. Rather than creating one new connection, you have a singleton class which will give you that connection object and only single connection object for each uh, time you called for that, each time you call or each time you want to get the connection for that particular main call, right? main call, or maybe sub child call, or main thread, child thread, child thread. Through until unless your main thread ends, you will have single instance of that particular object, connection object. So here what I have done, you have one value object. This is not the right example, only to show you I have taken this. Is you have this employee object. This employee object I have taken from the previous session. This is the employee object which you have here. Right. This employee object, I will create only one instance of it, not multiple instance of it. How you will create? How you are going to create one instance of it? If you create one instance of it, then you are implementing your singleton pattern. Right. So first of all thing, I should not allow, right? I should not allow other to create this employee object. So what I will do, I will make it private. Private, I'll create one constructor which is private. That means no one can create an object for employee, right? If we make the employee private, if we add a private constructor, the default constructor is private constructor, and we don't have any overloaded constructor there, or parameterized constructor, then no one will be able to create the object of this class, right? Do you think anyone can create object of this class? How they will create? They can't create it, right? So you cannot you cannot create an object of this class, and this employee class will be useless because you can't create an object, you cannot use it, right? So let me go the Creational. Yes. Second, where I kept that class. Employee Singleton. Yeah. See, this is actually I have done to test it here. What I will do, I will make the template class Singleton in front of you, and I will show you how it actually works. Right? This is one of the example which I have done. So no need of looking into employee singleton. Just see how this employee class can be made singleton here. I made this employee private constructor. That means if I go to the main class, you will see. Let me comment out these all code which I have written to show you. Right? You see now. Let's comment out this guy. Right? So I'm going to get an object of employee. How I will get the object of employee, right? So see, first you make this employee class as private. The construct of the employee class as private. That means no one can instantiate it, right? No one will be able to instantiate this particular class, right? So how can you will instantiate this class? You can do like this, public static dot get employee. Yeah, not here, sorry, here. Employee, then variable employee equal to new employee. See, this is how you can do. This is one of the way to do it. You know. Now, what will happen in this particular case? In this particular case, we have made it public static employee equal to new employee, right? Whenever this class is getting loaded, employee object get created, right? And that employee object can be accessed here directly in this particular place, right? Here you can do directly employee dot employee, right? This will give the object. But this is not the right approach to do it, and this can't guarantee you that each and every time you will get a singleton object. So always make it private static employee equal to new employee. See, there are so much theory is there available on the internet. If you want to read the theory, you can read it from there. I will just explain how you implement it. The practical this whatever my sessions are all are practical oriented sessions. Theory. If you have any doubt, you can always connect me. I will explain you. So what I will do here, public. I will make a method public static void. Right. Not void. It will return the employee. Right. So employee get employee. Now, right. So here, if this dot employee, if this dot, okay, not this, directly employee can write it is static, right? So static whereas if employee is not equal to none, right? Then employee equal to new. We created this employee object. If it is null, not equal to, sorry, if it is null, then we'll create an instance. If it is not null, that means already the employee object is there. So what to do? Return. This is how you implement singleton. This is very simple to implement singleton. Singleton is very simple. Similarly, your factory method is also very simple to implement. Now, how you will access this? Because it's a static method, you don't need to instantiate it, right? You just need employee dot here. Go to the main class here. Employee dot what get employee. That's it. You are done. This is called singleton implementation. See, I'm just trying to from line number 7 to line number 23. I'm just trying to, you know, print the hash code, print the hash code of the employee by calling it again and again to see if it is giving me another instance. It's just kind of a test for you. You all those are watching this video, to see this always gives what this always gives same object. That's why I'm printing the hash code you for your confirmation. If hash code is different, then it will be another object, right? So see, so let me run it. See, now it is giving some values, right? Some values it is printing that hash code value. If you see hash code value is always same, right? Hash code value is always same. So see, in this employee, I have avoided that hash code method. I think so. Some time back, we will comment that hash code method. We will try to get the natural, the original hash code implementation. Right. So let do it like this. Let comment this guy. Just call super dot hash code. Okay, super dot hash code will always super dot hash code will always return the original implementation, right? So let's call super dot hash code. And here also in equals to let's comment all this implementation. Rather let me comment out everything here, right? Why also support dot, let me comment out everything so that by default it will be taking the object class implementation, right? Okay. So now there is no hash code implementation, no equals method implementation, right? And let me take out this comparable also. Let me make a normal class, right? Now it is a normal class without any overridden or implementation. If you see, it's a normal class. Let me maximize so that I can see it. See, employee class, Private employee constructor, private static employee equal to new employee. If employee equal to null, then create new employee. If it is not null already, that means you already have employee object, return that object. And below the attributes or variable of the employee object, come down, only two string is overridden, nothing else, right? So that's how you see, this is how, uh, this is the implementation of your employee class with a singleton implementation. So see, value object are never made singleton. If you create value object as a singleton, what will happen? If you create value object as a singleton, what will happen? Never create value object as singleton. Never create value object as singleton. So let's never create your value object as singleton. What I will do, I'll remove this attribute, all this attribute, because we are only checking about singleton, right? Let let me name it as uh, connection, right? SQL connection or something, right? Let me rename it as SQL connection or something like that. Hmm. Employee value object or data transfer object will never be singleton. So that's why I'm updating this class. Otherwise, you people will say, those are watching, see, Satya said this is he has given an example employee singleton, and I also made employee singleton. So no, it's not that way. SQL connection, SQL connection class now it is singleton, right? So see, I'll just refactor this variable also. Because people what do they do, they create some kind of thing. So that's why I modified. See, singleton will never be, you cannot, your value object or data transfer object, DTO or VO will never be singleton. Keep it in mind. Okay, it never be singleton. So this is a connection, SQL connection. I'm making that singleton. Right. And see, I'm just replacing with get employee. Now I will run it again. See, now this is ID 17059296636, 736 whatever ID will come, 936 436 536, whatever. X, Y, Z, A, B, C, D, whatever ID will come, that I will, it will display it here. Right. This employee ID is here. So this is what singleton. This is what your singleton class, right? The singleton design pattern. Now how you will make this singleton design pattern as thread shape? You can do one way, that is by adding synchronized keyword. By adding synchronized keyword, by if you add if you add synchronized keyword, this is one way to do it, by adding synchronized keyword for the variable and for the, you know adding synchronized keyword, you can make it in the front of the method, you can make it thread shape. Also, by taking the lock of the object, that is another approach, is by taking the lock of the object. I will take, yeah, synchronized SQL connection, right, by adding a synchronized block for this particular class, right? So this way also you can make this as singleton uh, class as thread shape. This is how see the output is same. So that's how it is. That's how you make your singleton class. Okay. That's how you make your singleton class. Right? SQL connection is the class name, and this SQL connection I made this class as singleton class. No one should create an object directly of this class. This class will create its own object and will return it back. Right? So that is how singleton. Now we'll go to factory design pattern. Let's go to the internet and read the theory what they are telling about singleton pattern. Right? Singleton is a creational design pattern that lets you ensure that a class has only one instance while providing a global access point to this instance. So see, that's how it is. Here you can, if you see here, you also you will have the same examples, right? So this is how your singleton class. Now, what is factory method? The factory method is a creational design pattern that provides a solution to create product objects without the need to specify their concrete classes during the creation process. What it says, as I said, you have a factory which will create different object and will give you, right? So factory method clearly says you create, you know, without the need to specify the concrete class. What is a concrete class and what is not a concrete class? The abstract class or interface are not concrete class. They don't have the complete implementation, right? They don't have the complete implementation. The abstract class and your interface, they don't have complete implementation. That's why they are called as abstract and interface. The concrete class is the class which has the the video got disconnected. I started it again. So I will continue my session. If everything is gone well, that's fine. I will upload it. Otherwise, I will do recording again and upload. Anyway, I was talking about creational design pattern. So let me share my screen again. Yes, I was talking about factory design pattern, right? So in factory design pattern is basically a creational design pattern that provides a solution to create product objects without the need to specify the concrete classes during the creation process. See, concrete classes here. Sometime when in the very initial days when people talk about concrete, in my place, uh, in Odisha, the language in Odia with English, if they will say concrete. Like Hindi, English. Hindi plus English is called as English. Similarly, Odia plus English is or English. Now most of the regional language, when you talk, you add English words to that, right? So in my place, Odisha, people, when I was reading my engineering or diploma engineering or degree engineering time, people used to say concrete. What they mean by that concrete, cement. Cement, and you are mixing the chips, small chips with cement, sand, and you are mixing. You are making a solution of cement with sand and other kind of chips. So what actually happens? They call that as a concrete. You don't think about that all concrete. We are not talking about any construction things here. It is software industry. We are talking about software and software implementation. So concrete means a complete implementation of the class, not partial. Abstract class is a partial implementation of the class. Interface is not having any implementation. The complete implementation of class is called as concrete class, right? So what factory method is saying, you can always, you know, you can always create an object without specifying their concrete classes during the creation processes. While you're creating an object, you do not require to specify, you know, which object you need or which concrete class object you need, right? So see, when Spring Framework came, it implemented all this. It implemented all these applications. It implemented all these applications, all this design pattern, and you can directly use it. You need not require to worry. I need to have a singleton? Do I need to have a factory? Do I need to have a prototype? You don't need to worry about that. That's how the Spring um, framework has given their advantage to implement. Not only creational design pattern, Spring framework also has implemented structural and behavioral design patterns. So let's go ahead slowly, and in some of the session I will talk about Spring in future session. So you'll understand how it does there also. There you don't know, there you need not require to write a whole class as singleton. You can create a class and just configure it as singleton, then you will get a singleton instance from that class. Earlier, before in very beginning of Spring days, people used to only use XML, and now annotation is also supported. When you talk about Spring, I will tell you what is the difference between Spring, XML, and annotation. Where you can go for XML, where you can go for annotation. We'll talk about that. But anyway, let's come back to factory design pattern, right? So see, here you have printed this IDs 175 170592966. Similarly, if it is having different ID, it will give that different ID. So for example, let me show you one more. By doing so, one more run for that particular singleton class. For that particular, yeah, this is the class, right? Here, what I will do, I will just override the hash code method with my value. You can see it will give always that value. Yes. So here support hash code we are calling, right? What I will do, I will put something random, math.random, right? Math.random. What it gives double, right? Math.random, and then we will put here dot, we'll make that double to integer, right? Integer dot value of math not random, right? So it is giving double, what it has happened? Integer dot value of dot. Okay. Let me make it like this. Why this here has no term casting to it? Hmm. Hold on. Do something to show you something here. Okay. So this value now will return A. Right? This is the value which I'm going to return. See, always you got 0, 0, 0, 0, 0. Why? Because it might be giving a double value, and when you divide, it will be something 0 point something. So that's how it is coming, right? So what we will do, we will just divide like this. 1.0. You see what we are getting. Right? So everything is 0, 0, 0, 0, 0, right? So now I'll make you something else now. What I will do here, I will take this SQL connection. What I will do, where is that guy? Yeah, this system dot identity hascode, right? This I will take system dot identity hascode. So here we'll put something like this. System dot identity hascode, right? It will return what? What it will return? It will return the integer value, right? So what we'll put? We'll put here SQL class, same class, right? And we'll store that in this int, and we'll return that. See why I'm showing this to make sure that always it returns the same value whenever you call that singleton pattern. Whenever you call the employee dot SQL connection dot get SQL connection, whatever, whenever you call that, it will give you the same object. It will not give you any different object. So before going to factory pattern, I want to make sure that it happens that way. See 12976 85781. Now it starts giving the value of all same, right? So this is how you implement it. This is how you go ahead with it. This is called your singleton pattern. Now I think you all might have understood what is singleton pattern. You know, so I used to want to explain it a little more. That's why I came out of factory pattern to singleton pattern. Now I will go for factory pattern. What is factory pattern? It will allow, what it will do. I've given you so many example of this guy. Now I will go to this factory pattern and I'll give you some example. Right? See what it is saying. Without knowing the concrete class, you'll be able to create the object of concrete class. Right? See here I'm saying account factory get account object. I have taken a situation. I will tell you what problem statement I've taken here. The problem statement I've taken for factory design pattern is in banking system, you have saving accounts, you have current accounts, you have fixed deposit account, you have recurring deposit account, you have so many other accounts, right? So all these accounts object will given by this account factory class. Whatever you see here in line number, right here, page line number 33. Whatever you see, account factory dot get account object. This get account factory dot get account object will give you whatever object you need. Either it is saving account or it is fixed deposit account, it is recurring deposit account, or whatever account it is, right? It will give you that object, or it is current account, right? Whatever account it will give you. How it will give you that account information, right? So how you're going to implement that factory design pattern? See what I have done. I have taken one interface here called I account. If you see in many of the cases, I will be using, if it is an interface, I will use I in front of it to segregate or to clearly make it interface. And if it is abstract class, so I will use SC, then the class name. So here class name is account, I is interface. So it is an interface, it has, let's say, deposit and withdrawal method. This account interface has your deposit and withdrawal method. So I created a current account class. In current account class, will implement I account and it will override your deposit and the withdrawal method with the complete implementation. Here, what happened? Here, I just taken a dummy implementation to show you. Whenever I'm calling, it is written in the same instance of that class, and I am using that object to invoke that particular class method. That is the reason I've given you a system.out.println. If you see line number 7 and line number 13, it's only for that reason it has I've given. I've not implemented anything. 0 is for always unsuccess and one is for successful, right? And that's how it is. It should be, but you forget about the real implementation. I'm saying how the structure should be, how your class should look like, how your interface should look like, how your factory class should look like, right? So your current account implementing I account the same way recurring deposit account. I came to recurring deposit account, and this is also implementing deposit and withdrawal by taking I account into consideration. Then going to saving account, the same saving account implements I account and override the deposit and withdrawal method. Going to account, fixed account also does the same thing, implements I account and override deposit and withdrawal. Inside that, no concrete implementation, no business logic, no implementation, but I have given you system.out.println to show it is invoking that class. Now, how actually a single account factory class will give all these objects? Just watch it. Nowadays, no one is implementing all this because frameworks like Spring, framework like Spring, they're allowing you to configure your class to give you factory pattern, abstract factory pattern, prototype pattern, singleton pattern. So see this account factory class, right? See, this is what the best practice is. Whenever you use, whenever you have to use some constant, better have a constant class and you put the constant there and use it in the other class. See here, I will push this code to Git today or maybe after this session or maybe in another 24 hours, you'll be able to find this code in Git and you can check out this code or you can download this code and check the explanation with the video. You will understand it better, right? So this is the set of classes. Account factory is the class which where we will create all these objects. What actually account factory is doing? Account factory, I have one method called get account object, and this is again a static method, and it will return the object of type I account. Why it is I account? Because interface type, that is called dynamic polymorphism, right? Interface type. So what it does, it takes one parameter, account type. What is that account type? You have to pass either it is saving or it is current or it is fixed or it is what? Or it is recurring account, right? So accordingly it will give you the class. One second, let me write here. Current account is for current account. Let me write complete it here. Fixed account, recurring account. Well, sometimes you will get disturbed or distracted because of some reason. Don't look into that. You just continue watching this, complete this, you learn this. People will tell these are nowadays no one is using. Don't worry about that. Why no one is writing nowadays? Because frameworks are so user developer friendly. They have the configuration to do it. You configure it, your application will work in that way. But to know to understand how a framework is implementing all this, you need to understand what it is actually, right? How it is implemented. Then only you will be understand the framework in a better way. So here it goes. I modified, I just, earlier what happened, no, all the returns are saving account. So I just modified a current account, to fixed account, and fixed account, recurring account, in recurring account. You see account factory, what it does, it return get account object, string account type, get account object, string account type. Account constant value I am using here. Either without using this constant value, what I would have done, the other way, I would have done like this. I'll just show you. Savings or 7. Like this, I would have done whatever you see in line number 16, saving dot equals to account type, and you can easily check. But the best practice is to use constants. That is what Java, coding standards. So use constant and then the variable which is coming, check to be that, right? Or that's how you can do. So see, this is a simple implementation. There is nothing much in factory. If the user is sending, if the user is sending what? If the user is sending saving account, it will go, it will say, yes, it is saving account, return the object of saving account. If it is current account, return an object of current account. If it is fixed account, return an object of fixed account. If it is recurring account, return an object of recurring account. This is so simple. It's just kind of checking if else. Or you can also use switch. Nowadays switch is supporting string. You can use switch also. You see what I'm doing here in I account equal to null. Object type object equal to null. See why object I've created here, because this, if you see I account interface, right? What I'm passing, I should pass a deposit object here and withdrawal object here. You know, or a account object here which will have withdrawal and deposit information. But I have not created any implementation here. That's why I'm sending it object. Even if in saving account implementation also, where I've overridden the method, I've written object. When you do a real implementation, you have to write real uh, type of object you are passing through deposit method, right? So it's not real implementation. It's just it is just to explain what is factory design pattern. Don't look into the business logic in that deep. Understand what is factory design pattern, right? So coming to here, I used I account because it's a dynamic polymorphism, right? Then that account, what I'm doing, account factory dot get account object, and what I'm passing the constant saving account. It should give me the saving account object, and I should be able to perform the deposit and withdrawal. So let me run this program. See, it is saying com.example.creational service saving account deposit. That means what it did, it created an object and it gave us that object, and using that object we are able to deposit and withdraw, right, from saving account. Now see, in that same line number 33, I will change saving to current. Let me run it. See, now it is given current, right? Current account deposit. So there is something in current account. Let me go and give a space so that it will this deposit and this withdrawal will give you clearly. You will be able to see it. See, now current account deposit and withdrawal. Now what I will do, I will change that current account to fixed account, right? Just only changing that constant value I'm getting. See, and I did not require to change the account also, because it is always referring to I account. And I, what is I account? It is interface type. It is a super, right? Super. It is all the these accounts that are implementing I account. See, here also I think I need to give that space. Let me give the space here. Yes, space is not there. Let me give the space and see if I run it how it works. Right? Deposit and withdrawal. If I make it recurring account, it will give you recurring value. Before that, let me go and check recurring account if you have space. Otherwise, I'll give and then I'll run it. Otherwise, I again have to, I give the space and I'll run it. See how it is. See deposit and total recurring account. This is how it works, and the important is all of your classes should implement the same interface if you want to generate a factory of that particular interface type implementations. Otherwise, it won't happen. That is how your creational pattern. Abstract class is same, prototype is same, all are similar kind of implementation only. The concept was little bit changed. So you might have understood what is factory method design pattern. Now, you know. So let me tell you something about abstract factory. What is abstract factory? I will just tell the definition of others. I will not explain through programs. After abstract factory is a creational design pattern that lets you produce families of related objects their without specifying their concrete classes. So see, simply talking about family, what it does produce families of related objects without specifying their concrete classes. Let's say you have factory, you have abstract factory. How does it work actually? You know, let's say I will talk about car. Now car is a factory, right? But if you see different car as the factory, but different brand is you have there. Mercedes, BMW, and for Mercedes, BMW, Audi, you have different brands, right? Now, car factory can give you what? Audi brand, and Audi can give you its own models. you know. So that's how abstract is stated. That's how. And if you have anything, any concern, I can explain you. We'll have one-to-one session. So just you need to understand how abstract factory here he has given in this diagram. If you see abstract factory, spheric factory, and pyramid factory. That's how it is. Car in car you have different brand, Audi, BMW, Mercedes, and again BMW you have different models. In Audi you have different models. In Mercedes you have different models. That's how it works. There is something called builder pattern. There is something called prototype pattern. So let me tell you what is builder pattern. Builder is a creational design pattern that lets you construct complex objects step by step. The pattern allows to produce different types of representation of an object using the same construction code. You can build with like overloaded constructors. It's similar to overloaded constructor. You have overloaded constructor, right? And you construct the object by passing the different parameters. The same way it is builder design pattern. Prototype is a creational design that lets you copy existing object without making your code dependent on their class. Uh, this pattern allows you to copy existing object without making any dependent on other classes. That's how it works. Just simple code, to show how your prototype works, how this works. You know, See, you can use all these and you can create a object. Right. So when you talk about all these in details, if you want me to talk about all these in details, and if you want me to explain all these in details, let's connect. Message me, comment me, or mail me, or yeah, you can do that, and then we'll discuss about all this. We'll discuss in detail. So this is your creational design pattern. Now from creational design pattern, what we will do, we will go to uh, structural design pattern, behavioral design pattern, right? So what is a behavioral design pattern? What is a structural design pattern? We'll talk about that. Here also you can have the structural design pattern, right? This is, do they have here? Behavioral design pattern, structural design pattern. Maybe. Let me see. No. Let me open that, then I will go through explain program. I'll explain the program. behavioral design pattern, right? Go to behavioral design pattern somewhere. Okay, geeks for geeks, you can go. Let's see what they're explaining here. Any website you go, you find the same kind of see behavioral design pattern. This is a beautiful diagram they have here, right? These all are behavioral design chain of responsibilities, interpreter. See that the way they have named, right? They represent the way they have named. They work in that same manner. What is chain of responsibility? If you think in English dictionary, that means you have a list of responsibilities to be taken care, right? Or responsibilities given to different persons, individuals, right? So similarly, all of them are there. So let me go and explain you what is behavioral design pattern. If you see behavioral design patterns are a category of design pattern that focus on the interaction and communication between objects. It is always focused on interaction and communication between objects in behavioral design patterns. They help define how objects collaborate and distribute responsibility among them, making it easier to manage complex control flow and communication system. Right? This is simple theory. See, this theory. If I read, you might have understood it. You know, what is behavioral design pattern? It focuses on interaction and communication between objects. It always focuses on interaction and communication between objects. So you have multiple classes or you have multiple uh, states. How you're going to handle that? It particularly talks about that. Uh, I will tell you one design pattern here. State design pattern and chain of responsibility design pattern. I will implement that and I will show you. It is already implemented. I will just explain it to you. See, uh, when I was working, it's been a long time in my initial days when I started my career. That time, this state design pattern was implemented by us manually. We used to have a database table to maintain the state and objects. So many things we implemented to maintain the application flow state, right? Using the message, something called state machine or something called that design that approach. So state pattern you can always implement it to maintain or to maintain the your object state or application state or flow state, right? To maintain the flow state, you can always implement the state pattern. I'll give you one beautiful example. Your traffic light, right? Where your traffic light you have red, green, orange. They glow one after the other. They change their state based on some parameters, right? So how they change the state? A design pattern the state design pattern can be implemented or used to change their state when talking. So what example I have taken here for state design, for state design pattern, I will show you. Yeah. So here I have taken, a logistic, when you order from the cart, that kind of situation I've taken here. You place your order is received, and your order is delivered. That is what situation I have taken here, and I will explain that situation how it actually works in that particular stack. Right? First, we'll go to the code. See here what actually is there in this particular situation. In particular situation, first what will happen? You will go. You will book your order in your cart, right? Add to the cart. Then after adding to the cart, you pay. Once your pay is done, what happened? Then this will be shipped to your address, and then it will be delivered to your address, right? This is how the state pattern, right? This is how the workflow works. Currently there are so many business process management BPM and workflows, right? Like JBPM, Camunda, Activity. They inbuilt give this flow. You need not to write any pattern. You can easily track or you can easily track each state of your application using these workflow models. So let me explain here first what actually I have done here. And if you have any concern, always comment section is there in YouTube, right? You can put comment there. I order state. If you see, this is another interface, I order state. It is basically order state, where what is the state of your order, it is going to explain. The method is void nest order contest and void cancel order contest. Both of them are taking order contest. What is this order contest? See, order contest is basically a class which is going to always maintain the current state of the order, right? It will maintain the current state of the order always. So order contest has a constructor, right? And that constructor, what I'm doing, I'm creating current new order place state. This is the default state what I ever mentioned. Once the order is placed from that particular moment, I am taking the count. What is happening next? Order is placed, order is received, order is delivered. This is what the state I am taking here. So see here current state, new order placed state. That is the beginning state. Public void state set test set state. What it will do? This dot current state equal to state. This order context will always have your current state and proceed to next state, and the another state is called another thing is called if you want to cancel the order, it will always have these options. So set state is basically is going to set the current state, and proceed to next state is basically going to do what? Current state dot next this. That means it is going to move your application to the or move your status to the next state, right? So how it actually happens? See here, order delivery state. I order state implements I order state. That is next and cancel it has to implement or override, right? Here what I'm doing, here I'm passing the order context. Order is already delivered, right? If in the order delivery state, I'm saying order is already delivered. I'm not implementing the core business logic inside here, only to show you the design pattern, how it can be, how the pattern style, how it can be implemented. I have taken this piece of code, and here only what I'm showing system.out.println. That means the business logic got executed. And in cancel, what it is saying, cannot cancel order, cannot cancel this order. Order is already delivered because the on order delivered status, the order is delivered and you cannot cancel it, right? Before delivering of the order, if you cancel it, you can cancel it. Your shipment will get cancelled, then the order of the product will return back to the this thing. Then coming back to next is order placed state, right? Here also what I'm doing, order placed state, I order state, public void next, order contest. System.out.println order has been placed, moving to shift state, right? So when you place a order, what will happen after that? You have to move to shift state, and then it should be shift, right? So what happened? Contest dot set state new order shift state. Here I am setting in this particular nest. What should be the next state in order place state? It should be shift state. That's why I am setting contest dot set state new order shift state. Right? The order delivered state is the last state. That's why we don't have any contest here. We cannot set anything else. Right? The order is already delivered. Workflow gets end there. Right? So that's how it is. So before I can do one more good thing here, let me open the MS Paint, and then I will explain that how it goes. MS Paint is always a simple and easiest tool to explain. See, let me see my screen is set. Yes. The people those are working on Java, those are interested in Java, they will be knowing all this design pattern, or they have to understand this design pattern because these are very important. In as a Java programmer, you should know. So see, these sessions are only for engineering students. These are very basic for engineering students and freshers, those who are really wanted to know or learn and grow. For them, this is nothing. I'm doing any big, internet. I'm just writing the program and explaining you. In internet, you can also find the same thing. But someone has to explain. If someone explains, you understand it very easily. Shift, right? Order shift. Then is order delivered or product delivered, right? So if you see this diagram, this is what the simple flow in that particular state design pattern. I am state behavioral design pattern I am showing you. So after you put into cart, you pay it, you have done your payment, that means your order is placed. Then it will go for order shipped, then it will go for order delivered. This is what I am trying to show you and how it can be maintained with maintaining the state activity, you know, sequentially without creating any uh, without uh, managing it, without managing it while writing the code, um, without you tracking how it works in your one single file. Each and every individual state will track their own state and the next state. What will happen here when each individual they track their own state and what is the next state? The application flow happens very smoothly and easily. You will not require to worry where it got stuck. If you are manually, doing checking every time, each time, every time, uh, is this execution is done, is this execution is done, is this execution is done, then that is troublesome. You have to write so much of code. If you use state design pattern, all boilerplate code will go out of your uh, code base and your code base will be reduced, reusable, and more readable. That's how the pattern they help us. So see here, order place state. This is the first state, right? Then what will happen? Then order shift state. This is then order deliver state. If you see this diagram, what happened in order place state? I should go to shift state. In order shift state, I should go to order deliver state. Right? So this state should be maintained, and current state should know what will be the next state. Current state should know what will be the next state. And in some cases, current state will know previous state also. In some cases, current state will know previous state also. Right? So that's how the state application, that's how the state design pattern. We'll go through the theory also. Let me show you first this. See, all of the state classes that are going with IOTA state, and the IOTA state is the interface which has nest and cancel method. IOTA state has nest and cancel method. Here, if you see order placed is the first state. So in order placed state, nest method will definitely have next state. Order has been placed, moving to shift state, that is next state. And in shift state, what I have to do, I should set this contest object. But from where this contest is coming? See, from where this contest is coming. This contest is coming from the method input parameter. The contest is coming from the method input parameter, and this method input parameter will give us the contest. And on that contest, we will set it to the next order state. Right? That is, in case of order place state, the next state will be order shift state. And in order shift state, the next state will be order delivery state. Right? This is how it works. And order contest class, you already know, it is going to only set the state, current state, and proceed to next. Right? This is what it is going to do. So here, if you see, just let me enable it. and show you how it works. So here see, first you have to create the order contest. No, you have to create the order contest, because why? Without contest we cannot proceed further, because our order contest is basically what happens in order contest. Always we are setting the current test. That is the initial state of our application. Order contest is the initial state of the application where we state the current state, that is order placed state, right? And from there we move one after the order, one after the other. So when I create an instance of order contest, right? When I create an instance of order contest, right? What happens then? When I create an instance of order contest, what happens? So initial state will get registered. That is, initial state is what? Order place state. See, here it is. Initial contest is order place state, right? Initial contest is order place state, and this order place state will be default state or initial state or starting point of this state flow, right? Or this application flow. Now, in this creating object, it has already set the initial state. Now when I'm running it, I'm just printed system.out.println order workflow. Now order contest dot proceed to next. What I've written? Order contest dot proceed to next. What will happen when I write order contest dot proceed to next? What will happen? It is very simple. You do not require to call all other things, right? Proceed to next will always help you to what? Go to order contest. Let's see. See, proceed to next. What it is doing? Current state next dot this. What is this? This is basically order contest again. Right? Current state dot next. What is this current state? Order place test. Right? In order place state, what we have? If I do order place state dot next, you go to order place state dot next. What it is doing? Here again it is setting contest dot set state order shift status or order shift state, right? And it will again, what will happen here? This order contest dot set state. It will call what? It will call this guy set state. What it will do? It will set the current state to order shift state, right? And what will happen again? Now the current state become order shift state. Then if I call again proceed to next, the current state will be order shift state next this. Now if you go to order shift state, if you go to order shift state, what is there in order shift state? Yeah, contest technique is coming the same contest object. Set state new delivered new order delivered state. Right? Here again same contest dot set. That means it will go back to order contest. Here it will set state. That is what? Delivery order state. Now the current state will become the delivery order state. And after that, when you do current state dot next dot this, nothing is there, right? Nothing is there. Now current state is what? Now current state is order delivery state. After that, we don't have any state, so we need not require to worry about that. We need to end our flow here. So it is, I have only taken few flow to show you, but if you want, you can add more flows to that, right? So let me show you by running this flow. See what actually happens if I run this piece of code. See order workflow. That is the first which is coming from line number 15, and the order has been placed. That is from where? In when you go to this order proceed. Wait, I will do something here. Here this let's some more SOPs. SOPs initial state, right? Initial state order placed. So initial state order placed. No, and then we go to order delivered. No, then we go to order placed state. Right? In order placed state, order has been placed. Moving to shipped. Now order shipping. Right. So let me go to that thing workflow order workflow. Let me go and print it in the very beginning of the program before new. So what will happen now? The initial state also will come into place. So see it here. I'm running it now. Order workflow. Initial state, order placed. Order has been placed, that is the next state. Moving to shift state. So what I will do here, order placed state, I will remove order has been placed because already order placed. Moving to shift state. And then it is fine. The printing is fine now. See, order placed, moving to ship state, order has been shipped, moving to delivery state, right? Now, if I do one more process to next, what will happen? Anyone can any idea? See, anyway, no one is watching, so I have to only ask the question, I have to only reply. This video is for you, those who want to video, who want to watch this. See, now what happened next? Another order is moving to this, and then order is already delivered, right? That is delivered state. Where is that? Order is already delivered, right? Now, if I write one more, if I write one more, what will happen? Order to proceed to contest. Anyone? See, order is delivered because after that there is no state. We have not defined any state after that. So it will always say order to deliver. See, if I add one more, it will say the same thing. You have to understand the logic, how it is written. Then only you will be able to understand. See, order is delivered. So I cannot proceed to next because order is delivered is the last state for this workflow or for this state of the application. We started with the order placed, order shipped, order delivered. After that, there is no, there is no status, right? So you keep adding, what will happen? It will print order is delivered. You cannot go to the end state because the state is already end. You are at the end state. How you will go to the next state? There is no other state, right? So this is how the application. This is how the state flow diagram this is how the workflow is implemented in old days. Now there are so many framework where we need not require to worry. You can easily use the framework to implement. No, I have worked with JBPM workflow. I have worked with IBM process server workflow. I have also worked with activity and Commanda. These are different kind of workflow which they allow us to maintain the state of application. Uh, there are so many things. So let's not talk about that now. So moving to ship state, order has been shipped, this. What is next? Now, once the order is delivered, what will happen if I want to cancel it? Should I be allowed to cancel it? I should not be allowed to cancel it, right? So let me run it now. Cannot cancel order is already delivered, right? So let's see what will happen when I create one more order and then try it to cancel. New order and then try to cancel, right? What will happen? New order occur, initial state, order placed, order has been cancelled, right? So I have placed the order, then I tried to cancel it, it got cancelled. But once the order is delivered, you cannot cancel it. It will say order is already delivered, right? Immediately after payment, you can cancel it. Now, what I did below this, I have, below this, I have printed one more flow, order flow. Just check it. Here, what I will do, I will just use cancel order after some flow and see, let you see what happens. See, order workflow, order is already delivered, order is already delivered, cannot cancel, order is already delivered. See what happened now. Here, this order contest, right? I'm using the order contest as the object again and I'm trying to do it, the operation. Now, what the order contest object is holding? Order contest object is already used and the order contest object is already raised to deliver state. If I use the same object again and I want to cancel it or proceed to next state, what it will do? It will say me order is delivered, order is already delivered. So for that reason, what I need to do always, I need to create one more instance for that, and then only I can, initialize the flow and continue, and then continue. See, I created in line number 30 one more uh, new order context. Now, if you see whatever you are seeing order delivered, this message will be different now. See, order has been saved, moving to deliver state, cannot cancel, order is already delivered. Right? So see, the way you implement, that's how it happens. The way you implement, that's how it happens. Just you have placed your order and you try to cancel it, you are able to cancel it. But after it's moved to shipment, you want to cancel it, you will not be able to cancel it. See, initial state, order placed, moving to shift state, cannot cancel because it is already moved to shift state. Now it cannot be cancelled. You can only cancel it immediately after placing the order. That is how this state flow is implemented. You want to change, you can change the flow. You do your experiment with these examples, and you will be able to understand how it works. See, some of the examples which I have taken here, some of them are from my thought process, some of them are from the different places where I have read the book articles, or some of them I've taken from other places. This approach I'm taking, the approach to deliver this session I'm taking is always practical oriented approach. You understand the program, you understand how it is implemented. That is very important, right? So let me go. The person who has actually worked in Java, they will understand the need of state design pattern, where it is used. Those who have actually worked in workflow or BPMN, they will be able to understand where this design pattern is used. Right? State design pattern is very used. See, what is state design pattern? Now I will explain the theory. I just told you the implementation and the way how it works. The theory is here from the internet, again from the Geeks for Geeks. The state design pattern is a behavioral software design pattern that allows an object to alter its behavior when its internal state changes. It achieves this by encapsulating the object's behavior with a different state object, and the object itself dynamically switches between the state objects depending on its current state. This is the basic definition what they have written it here. That means what it is trying to say. the behavior, it allows to alter its behavior. All this behavioral design pattern will allow you to alter the behavior of the object, right? Or internal state of the object. Behavior when its internal state changes. For example, now if we see the order contest, the current state and next state, it's keep on changing, right? Sometimes it is shipped, sometimes sorry, initially it is placed, then it is shipped, then it is delivered. This state keeps on changing. The behavior of order contest keeps on changing, right? From current state to next state. So this is how the behavioral design pattern, you know, defines, and all the design patterns present in behavioral design pattern, they will always talk about objects behavior. The way creational design pattern was talking, what creational design pattern was talking, the creational design pattern was talking about creation of an object or creation of objects, right? Similarly, behavioral design pattern will talk behavior of that class or behavioral uh, of that particular object, how the behavior of the object changes based on the some situation, some condition, some criteria, right? So see, there are so many websites. You can read from so many websites about the definition. Medium is also one of the good website. Geeks for Geeks. You have Hacker Rank. In Hacker Rank, you will find design patterns, and you will also find different implements for these design patterns. You can go to the lit code. You can go to the Hacker Earth. You can read from the tutorials point, Java point. So many websites are there. You can go and read. Today, I will end this session here, and next session I will explain structural design pattern. Along with that, I will explain uh, one more design pattern from uh, this particular behavioral pattern. I will explain that, and then I will explain the structural design pattern. Right? There also, I will take um, one or two design patterns, or maybe yeah, one or two design patterns, and I will explain. If you really want to understand all the design patterns available in creational, structural, and behavioral, we can always have one-to-one session, and I will help you out, or I will share the knowledge I have with you for your understanding. Connect me. You can how you can connect me over the comment, YouTube video comment. You can probably you can put a comment on that YouTube video. If you need a session, if you need a session, one-to-one session, definitely I will reply back. You can mail me on my mail ID. You can message me on my LinkedIn profile. Definitely I will reply back, and we'll have one-to-one session and discussion. And all these sessions are only knowledge sharing session. I am not a trainer, so don't worry about that. I am just sharing my knowledge in my free time. And currently I'm looking for an opportunity. In between that, I have enough time, so I thought, so I am sharing all this video based on few based on few requests from the some students of engineering and from different sector. Those are reading computer science as a paper. They asked me to upload this. That's why I'm uploading this. You all, it's again different region. Again, I don't need any region to upload. It's again whenever I'm recording and uploading these videos, it is refreshing my knowledge also. Anyway, if you really want to learn more, connect me. I'll help you out. See, there's a difference between learning from a trainer and learning from a person who is really worked on these patterns and implemented these patterns without using any framework. Because nowadays, so many frameworks are there, and people are using lots of framework rather they are writing, because these frameworks are already tested and they are running in production efficiently. So when you have reusable artifacts available, why you will write your own piece of code and create? Again, you have to test. If you write your own piece of code, you have to test if it is working efficiently. Rather writing your own piece of code and testing it, but better use some framework which is already tested and delivered and used in production. Right? So Nowadays, no one writes a design pattern. It's already given by many frameworks. Hibernate, Session Factory design pattern, right? And Spring framework has implemented many design patterns. I will explain one of the design pattern called facet. One of the design pattern called facet. That is implemented by Spring. They have internally implemented facet design pattern. You can say aspect-oriented programming. Aspect-oriented programming internally uses facet design pattern. See, there are so many things like in Spring. If you talk about dependency injection or IOC, that uses prototype, Singleton, factory design pattern. There are so many things, you know. Slowly, I will record one of the video and I upload it. Keep watching and watch the next session of this particular design pattern. You will understand structural design pattern also. Thank you, everyone. I'll end this session here.